everybody. I think the number of people arriving is starting to slow down now. There's a few names I recognise on the list there, so welcome along. Nice to see you again. All right, this webinar, this A2K Win0 webinar is going to be looking at introducing the Innovyze products that Autodesk have acquired last year. Just a little to begin with, preamble, Win0, A2K have become, for many of our clients, a trusted technology advisor, and we work at all levels with people in their companies, training through to project support. Well, you may have seen that we're now branded as A2K Win0. That indicates that we've actually teamed up with a number of other companies around the world, covering 25 languages, 32 offices globally, and 550 employees. That being said, we've actually, you might be wondering what the 0 bit's about. We've actually got staff who are experts in environmental sustainability now. And so if your companies are looking at getting advice and help with trending towards carbon zero, that's what they are here to help you with. So if that's something you're interested in, get hold of your local A2K Win0 office and they can put you in touch. All right, today, for those who haven't met me before, my name is Dean Peterson, and I've been working as one of the lead civil technical supports or technical resources for A2K for the last 20 years or so. And the one thing one of the staff did point out to me just at the beginning of the week, and that's the little caveat I've got marked halfway down the page there: you don't have a hydrologist written on your little introductory page here. That's because I'm not a hydrologist in any way, manner or form, and I don't pretend or claim to be. Probably I am the worst hydrologist on this meeting, I suspect, at the moment. However, I have had a first go and look at these products, and that's what I'm hoping to give you a high-level overview today. We only have an hour, so we don't have a lot of time. That's all we're going to be able to manage in the time. So to talk about these Innovyze programs, it's a number of different products. We're actually going to only get a chance to look at two today. First one's info drainage, and that has a good link through to Civil 3D. So that's what I'm going to spend a wee bit of time on. Looking at that and going from Civil 3D into info drainage and back into Civil 3D again. That's, I think, what a lot of people will want to see. Then we will have again an overview look at InfoWorks ICM. Now, don't get confused with InfraWorks and InfoWorks. InfoWorks is the one we're going to look at, which is the water analysis side of things. So ICM stands for Integrated Catchment Modeling. And so that's the next step up from the info drainage, if you like. Info drainage is effectively a cut down version of the ICM. Then you've got InfoWorks WS Pro. That's, as you can see, for water distribution analysis. Water supply. I haven't had a look at any of these others yet, only the first ones. InfoWater is similar to InfoWorks WS, except it's working with ArcGIS. And ArcGIS users can use the functionality that way. And then we've got asset management stuff for water systems, going right through down to the Info360 plant here down the bottom for treatment plants. So with the caveat in mind that I really aren't a hydrologist, let's see what I've learnt so far. So I'm going to open up Civil 3D here to begin with, and we'll start with that. Now, for anybody that has seen any of my webcasts up on YouTube before, and that's where this will end up eventually. You may recognize this little model, and if you've done training with me, you'll probably recognize it as well. Just a little civil 3D model of a pipe network. The one thing that might be a bit different if you haven't used them before are these catchment areas. Now, these are in Civil 3D already. Make sure you are using the catchment areas that are the new type. So under the Analyze tab up here in the ribbon, there are these ones here, which is create catchment from surface. They're not the old type. The old type was to pick a surface and use this catchment area out of the ribbon. Don't use those. These are much better. They recognize when there's another catchment area next door and they don't overlap. They also, if I have a look at the properties of one of these, catchment properties, when you create them, you've got the ability to give them a reference pipe network structure. So all the water from this catchment is going to go into what structure? It's going to go into storm N7, and we can nominate or pick a pit for them to go into, or a sump, and that's the N7 there. Yep, that's it. And so that information will transfer across, as you'll see. So use the new ones out of the Analyze tab in the ribbon. Okay, let's have a look at the export function. So Innovyze drainage or info drainage. I said micro because it's actually this is the, as I understand it anyway, the next iteration, if you like, of what was called micro drainage is now these Innovyze products. So let's go, and when you load info drainage onto your machine, it will put in a ribbon into Civil 3D for you, which is the one we're seeing right now. And we've got this button here, export to info drainage. So I'm going to click on that. And it might take a moment to come up. It's got to go and find its license and things like that, I believe. At least I think that's what it's doing. Here it comes. And we want to tell it where we're going to write this out to. So I'm going to go to my desktop, put it there, just call it web for the web training. Going to go next. It'll look at all the networks in your drawing. This is the one I want to export. And I'd also like to export my surface. The surface in here is called final levels. So I'm going to export my final levels surface out to info drainage as well. Go next. By the way, if you've got any questions, put them in the chat or the Q&A in the meeting toolbar, and we'll hopefully have some bit of time at the end to have a look at those. Okay, once you get that nominated, it then goes through and asks you what these pipes that it's found in your network want to relate to or correlate to once they get over into info drainage. So these pipe sizes here, if it's given a found my 300 pipes, it's going to make them 300 millimeter internal diameter when it gets through to info drainage, Innovyze, and you can change those if they're not matching up properly. Now my 225 pipe there hasn't put the right diameter there. Also 225 is what it's going to be to make a 225 pipe in Innovyze. Okay, so that's the pipe mapping. We'll look at the junction mapping now that goes across, and I actually like the fact that it's asking you what you want to do, and you can change it manually rather than trying to do it automatically in the background, which some of you might have seen for things like SSA if you've tried those before. I actually think this is actually quite good. So we'll see that when we come back again as well. All right, so yep, my 650 max pit's going to be 950 by 650, and the manhole's going to be 1050 diameter when they go across. So that's all good. Go finish. And it will export those, and she's all done. All right, I'm going to leave this open. Just make it a bit smaller. And I'm going to open up the IDDX file, I believe is the right one, to go and open it. And again, it's going to take a moment to get its license and things. I've clicked it properly. There it goes. So I believe this product was actually made in the UK. Moving on from micro drainage. So it's not really American based like Civil 3D is. So that's quite nice. Okay, so here we go. So this is the info drainage, the one that works with Civil 3D. The other ones don't do a direct conversion across from Civil 3D like we've just seen. They may in the future, but at the moment they're not. So we've got a surface here. It's displayed differently from what we see it in Civil 3D, but if you don't like to see it, you can turn it on and off. Where is it? Here it is. So we've just got the tree view down the side here, which you might be used to from many other programs, and you can just choose to turn things on and off. I probably don't want those contours, get rid of those. And if I want to, I can actually go into the display settings for that surface and change the way the coloration's done. So I'm going to move that up, move that up, move that up, and it's just giving me a better color graduation there if that's what I want to do. That's nice and easy. What I can also do is, oops, where'd that go? Close that. Change the display settings for the size of these icons. So display settings, in plan, text height, I'm going to bump that down to about 5, I think. And the icon height to about 10, something like that. Just to make things a little bit easier to see what I'm doing in a model this size. So you can see my catchments have come through. They are linked to those structures that that was done in Civil 3D, so that's nice. All the pipes are here. I can click on one of those, and all the pipe sizes and things and their levels will come through as you'd expect them to. The catchments themselves, double click on those, and you can go through and change all your catchment properties. The dynamic sizing, there is two types of, well, there is a pipe sizing function up here in the ribbon here somewhere. Preliminary sizing. I believe that's the top one here, preliminary sizing. Yep, that makes sense. Which is a quick analysis and just a quick pipe sizing for you. If you haven't done it already, most of the time you're going to know what pipes you just want to check, in which case the full analysis is this bottom one. The runoff method is a simple time of concentration here at the moment, but you've got many other options. Modified rational, swim, what's the other ones I've seen used? SCS I've seen people use here. And each one of those will give you a different parameters that you fill out for your particular catchment area. I'm just going to leave that on time of concentration here at the moment. I'm not going to change any of those for limits for time, but of course you can. And then you've actually got pollution buildup that can be monitored as well. Put in path lengths and things, and it looks like each one can have a storage tank as well on them. Speaking of that, so I'm okay with that. I'll cancel that out of there. No, I'm going to change. Speaking of that, there are other objects. So for instance, if I zoom in down here, we can, under build here, add other stormwater controls, such as a bioretention pond. all sorts of other ones, actual ponds, infiltration trench, a swale, and all of these have the ability for water to be lost out of the system by infiltration. So, and the cellular storage, underground storage, tanks and pipes as well. So if I just show you one of these quickly, you just sketch the size you want it to be represented as. Oops, sorry. And that's just what it's going to show up on the plan view. There we go. And it's a little bioretention pond, and it's got all its own properties and things that you can define. It's picked up those dimensions, but you can obviously override those with filtration layers. There's actually an image down the bottom here that shows you what all these things are that you're typing in, which is actually quite useful. Inlets, outlets, and you can simply take your pipes and connect them through that bioretention structure, and that will be analyzed at the same time as all your pipes. Not going to do that. I'm going to keep it the same as Civil 3D for now, but all of that functionality is in here, which is good. That's what we're going to be doing or needing very soon, if you're not doing it already. So that's a big part of what these programs do, is have that extra functionality. Okay. We need to go and have a look now at the rainfall manager here. So the input of the storms that you can apply. So I've got the rainfall manager. For those in Australia, you'll be pleased to know the AR&R, Australian Rainfall and Runoff, I believe it means, is already in here. For New Zealanders, unfortunately, we're going to have to use a user-defined rainfall to get our data, or there is IDF curves down here if you want to define those. However, let me show you this AR&R, because I think most people on this call are actually from Australia. If I add one of those, it gives you the wee map, and you can go and get the data for any place, any part of Australia that you want. And so I'm going to go down to Melbourne down here and say my project is there, shall we say, out by the airport. And you can click the download button at the bottom and it'll go get all the data that you want. Now, just to save time, I've done that already and downloaded it. It's just a few files that it needs to go and grab for that particular part of Australia, which is nice. So I'm actually just going to load them up down here manually. And if you have your own files already, you can just load them up the same way. So it's the hub data text file, the BOM design rainfall, and the BOM coefficients is there. Okay, I did actually get those ones just from this map from the public data. So that being done, we need to probably have a look at the other tabs up the top here. Well, we do actually. So what's the expected rainfall frequency? So that's our AEPs. I'll put another one in here. Whoops, another one line in there by clicking on the add. So let's do, for this analysis, we'll just do a few. Let's look at the 2-year return period, which is the 50% chance of occurring, and the 100-year 1% chance of occurring. We'll do both of those. Obviously, you can do as many as you want. We'll just take longer to calculate. Storm durations that we want, you can select as many as you want. Let's just, for this one, let's do a quick cloud burst, 7.17 of an hour. Let's do a 2-hour storm. Let's do a 24-hour as well. I guess that would probably do maybe a 3-hour as well. What the hell? That'll do for now. but obviously you choose the ones you want. Then there is an aerial reduction factor as well. I haven't actually got one of those, a file for one of those, so we'll just leave that off for the moment, but that's all there. All right, so that's nice for you guys in Australia. So I'm going to go okay. And have a look at the analysis criteria now. Once we're in here, we're going to do the full dynamic analysis rather than the quick static. We'll tick on that rainfall or those rainfall events that we wanted. So it's actually going to calculate 80 different storms. And here's the output interval for the results. Every 5 minutes, it'll do a result. So I'm happy with that. Time step, you've got a couple of options for time step for the analysis. Now, I believe it's the SWMM method of analysis it's based on, the whole program. So, but the default seems to work pretty well. It seems to be very, very stable. So that's quite nice. Urban creep. So that's if you're expecting, the amount of impervious areas to increase over time. I believe that's what that's for, which is this figure here. And the junction flood risk, I believe that's 300 millimeters below the lid of a pit. It will assume that that's meaning you need to be worried about overtopping at that point, and it will flag it. And it can do a flush analysis first, but I'm not going to do that. That's all I need. So we'll go okay. Now you guys, as I say, being the AR&R method, you'll have a better idea of what you're actually wanting to input, because as I say, I'm no hydrologist and I haven't actually ever used the AR&R method, but hopefully what I've shown you there makes sense. I'm been making that one up as best as I can. I think that's how you'd use it. I assume that's right. Let me know if it's not. The thing we want to do now is probably check that everything I've set up is good for analysis. So let's go to the, let me see, analysis tab up in the ribbon. There's a validate here, little tick mark, click on that. It'll have a look at the model, and we do have some issues. Okay, so these first ones here, all of those there, it says match invert elevation to the lowest connection invert elevation. So it's slightly mismatched between the data that's read from Civil 3D, the bottom of the structures, and the lowest pipe. And the thing I'm seeing here, it's only a few millimeters, like 4 millimeters, 3 millimeters different. So I'm happy with all those. I'm going to tick those on, and the software will fix those up so it can run the analysis. This one here, match connection elevation to the upstream invert elevation. Again, a couple of millimeters. That's not going to make any difference to my model. It's below survey accuracy anyway. So we'll fix all those. We'll go okay. And we'll go validate again, and it's all good, ready to go. So I'm happy. I can run my analysis. I'm going to click on the go. And it shouldn't take too long. Okay, and so we're looking here at each of the pipes. This is the connection summary. The connections are the pipes, each of the pipes, and we're looking at the one storm here at the top here, which is actually the one shown down the bottom here. Now, the thing we probably want to do is look at the critical storm for each pipe. So I'm going to click on critical storm at the top here to see the worst case scenario. And here's one that's surcharged. Okay, these are the things you're looking for. And the flow over its capacity is 3.5. So it's well being flooded or surcharged. So we probably need to see where that is. It's Storm P6. Now, so far, I don't think I've actually found, or capacity exceeded here. Yeah, there we go. And it highlights it in red when you click that button. I don't think I've actually seen if you can double click on this and actually zoom. I'm pretty sure you can't zoom to that pipe, but it does highlight it as red in the plan view. So here it is. I can go and have a look at that, but I can also get a long section through this, which is quite nice. So if I go and add a flow path from there to there, it has actually, this had a wing wall on the bottom of it in Civil 3D. It's actually converted that to an outlet already. It just figured out that was the lowest pipe. It must be an outlet. So let's do that. Oops, as a flow path. I can rename that if I want to, but I can also get a profile from it. So there's my profile. These are customizable in the display settings here to change how they look, but they're actually not bad. There's a couple of buttons up the top here. There's the minimum cover depth line, which is what that is. You can set that depth somewhere. I think it's in those settings, but I'm going to turn that off just to make it easier to see. Sorry, that's the HGL. There's the minimum cover. That one there can go off. I want the HGL on. And if we zoom in on this, we can have a look at that Storm P6, the problem pipe. And if there's a play button down the bottom, we can actually get a graphic. It goes really fast actually for a storm this quick. So you can actually just use the scroll to come through, and there you can see that is full at that point and going back down again. Now, the critical storm, I think it was number 7 was the one for that pipe. So it is backing up in there in the pit, but it's not actually overtopping. So that's okay. But the pipe is surcharged. It'll be getting close, I guess, to starting to overtop. So we probably want to do something about it. So we want to bump it up probably in size, I would think. So I'm going to come into here, and we want to show this round trip anyway. Pick on that, double click on it, and instead of a 225, let's make it something that's got plenty of capacity. Let's make it a 375. So we'll see that change happen. Make it a 375, go okay, rerun my analysis, and it should be all good. Being a 375 is massively huge. Go. Okay, and again, look at the critical storm. Actually 0.92, so it's still getting up there, but it's not surcharged anymore. So that's good. I did go big enough, and yes, it was Storm 7 was the critical one, as shown over here. All those are different storm events for each pipe. It'll be a different storm that's the critical one. So that being said, let's go and take this back to Civil 3D. So I'm going to save, and we'll see that change come back in theory, hopefully, if I keep my fingers crossed, because that actually had a problem. Now this is, if I go to the file, no, not the file tab, plan, no. Here we go, about this version that I'm using of info drainage is 2023.3. 0.2 and previous, when you take it back to Civil 3D, was crashing, at least mine anyway. In this version, this is the one you want, because the ANZ parts list seemed to be the problem. They fixed it for the UK and Ireland parts list to work. They were getting a similar crashing issue, and it's fixed ours as well. So make sure if you're using this, or if you're going to, make sure you're at least using 2023.3 version or later. Okay, let's just save, we've done that. Let's go back to civil. And let's bring it back. So from the info drainage tab in the ribbon, import from info drainage. The file to import will be the one on my desktop that we've just been playing with. Go next. The storm that we're analyzing is, or the phase is called storm. The network we want to bring in is it's called storm in Civil 3D as well. That's what I called it. And for the surface, we're going to tell it not to change the surface. We're going to just keep this one in our drawing. So use the existing Civil 3D surface. It'll then find all the pipes in the InfoWorks, and it says what do you want to convert them to when they come back. So they're all going to be RCRRJs for me. And we've got a 300. And this is where you get to choose it, the one you want. It doesn't try and do it automatically, which means it doesn't stuff it up. So I quite like this system. It doesn't take long to do. 300 on the board, 450. So it doesn't grab the wrong one, the one you didn't expect it to do, which has been a problem with other export to analysis before. 450 and a 375 class 3. And class 3 because it's under the road. So 375, 450 and 300. Cool. And also the junctions. So that rectangular one was the sumps or pits, and it's a 950 by 650 pit. And the manholes, circular manhole, is our 1050 diameter concrete manhole. All right, down the bottom, I'm going to go finish. It's going to import those. And once it's finished, doesn't jump there. There is our, used to be a 225. Now it's a 375. You can see the size is 0.381 there, but if I go and have a look at its properties, we will see that it is 375 class 3, exactly what I told it to be. All right, the only thing I can see bringing it back, if you have some that are RCRJ, other ones that might be a 375, I don't know. PVC pipe or something like that, maybe. You'd need to identify those somehow so that they're slightly different. So I'd actually make one a 375 in info drainage, and the other one maybe a 376 or a 374, and just note that if it says a 374 diameter, that's what I was using for my my plastic pipes, and then you'd have those in the list to make as separate pipes when they come back. So it would probably be able to get around mixed networks that way. Okay, so that's come through, and we should be all good. And so if you have a close look at this, it hasn't actually affected anything else that it shouldn't have. All the pits here are the same orientation that they were before. And the manhole as well, you can see it's skewed off to the side. The only thing that it has done is we don't have the wing wall on the end anymore, in which case you just need to go and find over in the side here your, it's actually got a null structure there. Just select the null structure and convert it back to a wing wall. And you'll find, well, actually we'll do it just quick as we've got a little bit of time. You'll find that the orientation is still all there as it was previously. So the null structure is there. Go and select it. Right click. Swap part to back to the wing wall that it was. So that's the only thing I've seen that gets changed so far anyway. Put one of those on it. Okay, and there it is. And it's at the right orientation that it was before it left. So that being said, that is info drainage. Now what I want to look at next is the next step. So this is relatively easy. This, as far as I can tell, is a cut down version of the full ICM. So let's go and have a look at what the full ICM is. This is what I would get into big trouble with, not being a proper hydrologist. As you may well know, hydrology is something of a black art. We need the practitioners of that black art to be the ones that use this. It's massive. It's absolutely huge, what it can do. We're going to have a look at what, in particular, 1D and 2D flood analysis. So there is, I believe, back in info drainage, the ability to do a 2D flood analysis, but we've got it even more capable in here. So if we actually bring up one of the, yeah, we'll bring up one of these. Here is a model that somebody spent a lot of time building. So that's why I haven't gone and done this myself. Somebody's gone crazy bananas on this one. But it gives a good idea of what you can do if you know what you're doing. We have a big 1D analysis, which is all our pipes and our structures. We also have in here, if I can pick it, the 2D zone. That area has a surface on it. Now, you might have seen these 2D analyses were talked about before. What they are is, or why it's called 2D, always confused me. So if we go and have a look at one of these, 3D view, and bang it into 3D, the actual surface or the way it works, so we've got a 3D view here, and you can go under the ground and see all the structures underground if you want. Somebody spent the time to actually lift up those as buildings and put impervious roofs on those and discharge that into the pipe system. Everything else is done as runoff, but the runoff, if I can just zoom in carefully. Okay, here we go. Here is why it's called a 2D analysis. We've got the triangulation that came from the surface, but they aren't sloped triangles. They are flat. So they are two-dimensional faces. They're flat. But that's how it works out the flow from one to the next lowest one next to it, to find all the ones around it and find the most lowest one next to that. And that's how it routes the flow. So that's why it's called a 2D analysis, I believe, anyway, as far as I can tell. That's my understanding. But let's have a look what you can do with this. So this particular, I'll bring this one back up again. Flow from swales. This particular model has been set up with a rainfall event to try and figure out what happened when, in this particular town, and I'm not sure quite where this town is. It's a data set I got from Autodesk, but it might be in the UK. What happened with a particular storm that caused a lot of flooding. So they've modeled everything, or they had everything modeled perhaps already, and they can run the same storm event across it. In fact, if we go and have a look at it, no, not 3D view, rainfall visual. They've actually programmed in, here we go, the rainfall event. So if I hit, there's a play button up the top here. So from, I believe, the rain radar on that particular day, they have got the intensities that occurred. So there was a storm that came across the catchment to begin with, a little one. Then shortly thereafter, a huge one came in from the north. Okay, massive amount of rainfall, and that caused a lot of flooding. So they've taken the rain radar records, and eventually that'll disappear off to the east, I think. There she goes, calming down now and gone. Okay, so they're actually playing a real rainfall event through the system. From that, we can get the results. I'm going to go for the swales one. And again, we can play the results. So this particular graph here is actually for, there's a little pipe coming out of these swales underneath the road, or I think it's underneath the road. That's what this graph is for. So if I go back to the beginning and we'll zoom out a bit. Now, what they've also modeled is the reach of all this river here and the cross section of all the river. And there is a flow in there originally. There's actually water landing on the mesh can go into the river, and the river can put water onto the mesh if it wants to. As well as the 1D area where the pipes are up to the north, which doesn't have a surface. It's all the catchments are putting the inflow into that system. And that's flowing down through under where the mesh is. But the mesh is where they wanted to have a look at the actual flood event. There's a couple of swales here, as you might have seen in the 3D view, that are already depressions in the surface that came from potentially Civil 3D. And we'll see those being affected and filling up during the storm as well. But anyway, let's just run the storm. So I'm going to hit the play button, and hopefully it will take a little while to go through it. So it's going through, it's at 10 minutes at the moment, and going on through up the top here. So that's up in the top right-hand corner where I'm looking here for the progress of that green bar. And we should shortly see some things start to happen. There we go. So if I pause it there, what this is we're looking at, if I zoom in on these, overland flow being traced. Now this is coming from the surface, rainfall falling on the surface, as well as if these pits are being overtopped as well, it'll be coming out of the pits and onto the surface. There's a lot of it going on down here, so they got a real problem here. And it's ponding on the surface here. As I play it, those will stop and the ponding will go down again because it's flowing back into all the pits and manholes. So I'll just play it again, you'll see that happen. Overland flow is slowing down now, the rainfall event is slowing down, and you can see these diminishing now right down to what's left at the end. And presumably this area may actually be a low point below those. Oh no, it looks like it still may be flowing to the south. So if we left the analysis to run longer, it may actually dissipate, or it may be a low area that just collects there all the time. There's certainly some of those up in the park here. Okay, any of these pipes and structures you can get the information out of. That one that was up to the north, up here, this one out of the swales, that's what this flow graph is. And you can actually go through the analysis by taking this little yellow, red, I'm not colorblind, honest, slider out of here. So here is the starting conditions for up in the top here in those swales. Here is that first rainfall event, the little one that went across the city, going through to just before the big one. Big one is the peak of the big one. You see it's all flooding and the swales are filling up, and we're actually getting flow across here at the same time between the two swales across the road. Not sure if there's a pipe under there, but it's certainly, if there is, it's being overtopped. And then going through the rest of the storm. So you don't have to play it. You can just scroll through to the part you're interested in, which is quite nice. And that's still dissipating the last water out of these swales through that pipe at the bottom. If we want to analyze other things, we can. So any of these, I might close that one. Any of these structures, you can double click on it and you get, so it's a manhole there. You should be able to get some node graph results. It's the node we're looking at. And what do you want to see? I want to see the, you can do flooding onto or off the 2D zone if you want to, or from the 2D zone. You can do, what do we want? We probably just want the flow through it if we can find flow. Flood volume, no, flood depth, yeah, you could do that. Inflow into there. And it'll produce the graph for that. So that's the storm event. That's the first little bump there from the first little bit of rain that went across the city. And then we've got a much bigger one. And so the maximum inflow there, you can see is what, 0.45 of a cubic. And you can get all your Excel graphs and things out of this, as well as masses of those you can produce. But what you might be more interested in is getting some more interesting results from this overland flow maybe. So we can actually just generate a line here, a results line. So I'm going to draw a line that simply goes from across the road. And draw. No, it hasn't. Oh, yes, it has draw. Nope, sorry. I'm just trying to get my right click, left click to work here. So I'll try that again. There to there. There we go. And it was double left click. This will be called, I don't know, road line. And it'll be a results, and we'll go okay. And so with that, we can pick on it now. And we can right click, or we can use this button up here to go and generate a graph from it. And it's the road line that we want to generate a graph from. Let's go flow through the line. And there is the flow through the line over time. And you can just use that time slider again to see what's going on. There's a little bit at the beginning there. Yep, as you can see. And you can get other graphs as well, of course. So if I click on that again, road line, I'm going to have the highest depth along that line. So there's the maximum depth line as well. So you can see we got flow through that line was in cubics, 15, 16, almost 17 cubics, which is a lot. And the depth was just over 1 meter deep. So yeah, no wonder it was 1 meter deep if it was 17 cubics across the road. So issues there, obviously, or you're going to need to put a bigger pipe underneath, I guess. Okay. And I think pretty much that gives us a little bit of time for questions at the end, but that's pretty much what I wanted to demonstrate. Very high level overview of both, but obviously we're just about out of time anyway, so that's about all we could do in the time. Let's have a look at the questions, I guess. So back to my little...